All right, hello. Welcome back because we're going to do a video on VMware file system, right? Now you know the others. Let's get into this right away. So virtual machine file system, it's VMFS. It's a cluster file system. It's optimized, though, to store virtual machine files, including virtual disks in VMware vSphere. And this is how you get the most effective storage virtualization. VMFS is a high-performance, reliable proprietary file system. It's designed to run virtual machines, or VMs, in a scalable environment, from small to large and even extra-large data centers. VMware vSphere, VMFS, functions as a volume manager. It allows you to store VM files in logical containers called VMFS data stores. So the VMFS file system, or VMFS, it can be created on SCSI-based disks, directly attached SCSI and SAS disks, actually, and on block storage accessed via iSCSI, Fiber Channel, the FC, and Fiber Channel over Ethernet, or FCOE. VMFS operates on disks attached to ESXi servers, but not on computers running VMware Workstation or VMware Player. So VMware VMFS, it's evolved significantly since the release of the first version. Here's a short overview of VMFS versions so that you can track main changes and features. VMFS 1 was used for ESX Server 1.x. So this version of VMware VMFS didn't actually support the clustering feature and was used only on one server at a time. Concurrent access by multiple servers just couldn't do it. VMFS 2 was used on ESX Server 2.x and forward, and sometimes on ESX 3.x. But you got to remember that VMFS 2 didn't have a structure of directories. See, VMFS 3 was used on ESXi Server 3.x and ESXi Server 4.x and vSphere. So that's where you get your support for directory structure, because it was added in VMFS 3. The maximum file system is 50 terabytes. The maximum logical unit number, LUN size, though, is 2 terabytes. So ESXi 7.0 does not support VMFS 3. VMFS 5. This got used starting from VMware vSphere 5.x. The volume, or file system size, was increased to 64 terabytes, and the maximum VMDK size increased to 62 for VMFS 5. However, ESXi 5.5 supports the maximum file size of VMDK virtual disks of 2 terabytes. Support of the GPT partition layout was then added, so both GPT and MBR are supported. The previous VMFS versions support only the MBR. VMFS 6 was released in vSphere 6.5, and you'll see it in use in vSphere 6.7, vSphere 7.0, and newer versions such as vSphere 7.0 Update 3. So I want to take you through a bit of a comparison here with some of the most recent versions of VMware VMFS. We've got VMFS 5 and VMFS 6 set up for you. You'll find these two VMFS versions are widely used in organizations with VMware vSphere environments. VMFS 6 was redesigned significantly to meet the most modern requirements of virtualization. But before we get to that comparison table, I just want to explain a couple of the acronyms and terms used in the table. You've heard me mention the LUN, logical unit number. So this is going to be used to identify a logical unit on a SCSI-based disk by adding an addressing scheme, bus address ID LUN. So the LUN is limited storage space on a disk or disk array, presented as a block storage device accessed with SCSI. So LUNs are logical devices created on the storage system side and allow you to identify multiple devices on a single address. A LUN can occupy the entire SCSI-based storage array or a physical disk drive and a disk drive can contain multiple LUNs. Partitions and VMFS data stores, or VMFS volumes, are created on a LUN to store files. Now, creating more than one VMFS data store on a single LUN is actually not recommended and cannot even be done in the web interface of VMware vSphere Client and VMware Host Client. So the term LUN is often used interchangeably with the terms disk or drive. 512N. So traditionally, hard disk drives, HDDs, supported 512 byte-sized physical sectors. When physical and logical sectors are aligned, no additional manipulations are required. So the 512 byte sector size is referred to as the legacy sector size. 512E. Later on, storage vendors introduced the advanced format for the disks that they produce, and they increased the sector size to 4 kilobytes. Increasing the sector size allows vendors to use less space to store service information for each sector in the appropriate sections. That's gap, error correction code, ECC, sync, address mark, and as a result, it improved efficiency for larger disk drives for 4 terabytes and more. Now, the fact that the geometric size of sectors on magnetic plates is reduced and the need to preserve the efficiency of error correction are taken into account. So, to preserve compatibility with existing hardware and software, including an operating system, 512 byte sectors are emulated by physical 4 kilobyte sectors on hard disk drives and solid-state drives as well. The disadvantage, though, is that older operating systems don't support sector alignment for disks with advanced format. 4KN. So, a 4K native disk drive doesn't actually emulate 512 byte sectors. See, the size of both physical and logical sectors is 4,096 bytes. Hardware, including storage controllers like a RAID controller, and software, an operating system or hypervisor, but you could also consider in there device drivers and a file system, working with 4K and disk drives must actually support native 4K sectors. So this rule is also true for VMware ESXi and VMFS, starting from version 6.7. VMware vSphere supports 4K and disk drives. The advantage of using 4K and disk drives is that there is no overhead to emulate 512 byte sectors, and as a result of that, performance is slightly increased. Then comes the MBR, or Master Boot Record. So this is a partition table format. It's used for disk drives that are no larger than 2.2 terabytes. MBR supports up to 4 primary partitions on a disk. The GPT, or GUID partition table. This is that new partition table format that we've been talking about, and it supports creating partitions larger than 2 terabytes. It also allows you to create more than 4 primary partitions. Raw device mapping, RDM. This is a feature that will allow you to attach a physical storage device, or LUN, to a VM directly. All right? So now you know all about the VMware file system, and where are we going to go next? You'll see when you spark up the next video. See you then.